All right, here we go with module two. So we will be going through mechanical systems on this one. Pretty pretty big animal to take on. So there's a lot of information in this module. I'm just going to kind of walk through a little bit. It's laid out exactly the same way as your plumbing one from module one, and your electrical and low voltage controls for module three. Um, Again, you have your objectives here and your module guide. So I've sort of broken this whole topic down into three general categories. We have forced air guide, we have steam and hydronic systems, and we have refrigeration, air conditioning. So you'll see down below we have the topics. The one topic is sort of extra I threw in is comfort versus indoor air quality and lead. So there's a brief PowerPoint on that. Looks something like this. The basics of comfort obviously is what we're trying to accomplish when it comes to mechanical systems and HVAC units. So I'll let you guys go through these things, understanding temperature, humidity, ventilation, where are we? Circulation, filtration, and ventilation, right? But then getting into indoor air quality, what that means, why it's so complicated to test for it, because there's not really a standard as to what good IAQ is or anything like that. So we're typically testing for with indoor air quality is what is our temperature, what is our humidity, are we within the parameters, and then a lot of times we also add in carbon dioxide. We can also throw in things like carbon monoxide. So this alone requires proper filtration, ventilation, and circulation all throughout. So it all kind of ties back into comfort to have indoor air quality. Other things that are very difficult to deal with is geography plays a big role in air quality. We have different externalities to face, whether you're in Texas versus Washington versus, one part of Washington or another, or one part of an individual state. So you're dealing with different factors, different toxins, different pollutants. So your air quality measures are different. So it's very hard to set a standard because you can't control what the external environment is really doing. Um, it is important to note, though, that we, because humidity is such a big deal, we want to maintain a nice temperate humidity, that if there is any kind of water event, you generally have about 48 hours of a window to dry the space out before we can start molding. Um, Mold is kind of a big deal, um, but a lot of people don't understand also that black mold is something that requires an awful lot of humidity and an awful lot of at a pretty high temperature for a very extended amount of time. So generally speaking, we don't get black mold anywhere north of about Tennessee, even though mold is maybe black in nature or the color of it you'll see in the northern areas. It's not what we would consider black mold. So just make note of that. Lead, I don't get into lead too much just because this is a gigantic, this is an entire industry in itself. But its leadership in energy and environmental design, why I bring this up here is even though it has to do with the entire design, building, and operation process, um, if you don't have your mechanical systems up to par, you really are not going to get LEED certified on your buildings. So we can use recycled content, we can do all the processes and everything properly, but it really comes down to your mechanical components and how well they operate for the building's efficiency and lifespan. So that's why I kind of throw LEED in here as just what it is. I've done a lot of LEED buildings in my time. I think I've had my battles with the LEED process, but I think in general it's a good thing. It's a promotion of awareness for, you know, of environmental responsibility. It's attempting a lot more standardization across the industry. The problem with the standardization is how how different geographical climates or climate regions are affected the same way. So for a long time, for instance, what I had a big problem with was we were always fighting in Michigan. We'd have to put white roofs on a building in Michigan where we have actually a lot more heating degree days than we have cooling degree days. So in theory then, because we are reflecting more of the sun's light away, we are making our mechanical equipment work harder all year round to try to heat the space and cool the space out. It's really more about cooling the space off at that point. Um, but we couldn't get it without the lead points, but then it makes it a lot harder for us to get the lead points and mechanical components. So it's getting a lot better. This slide kind of shows that there's a lot of different, I guess it doesn't show it. Lead partner with a lot of other agencies as well that are creating a little bit more of a standard that I think makes a lot more sense. Um, it has also enhanced most of the general design parameters throughout the industry that almost every building you can make or that you can build nowadays would meet LEED standards. It's whether or not you want to go after the certification or not. And that certification is extremely expensive, so a lot of people opt to not do it. There's also been a lot of skepticism on how different items are weighed in the rating system. So again, I had a problem with, for instance, we'd be a point or two away from getting to the next level. Maybe it's LEED silver. Plan would be to then, add bike racks or add low emission vehicle parking signs or something along those lines where it would get you a point, just to add more stuff to your project. In reality, adding the bike racks doesn't really entice more people to ride your bike there. I don't think. I've seen it happen a lot of times where you just throw bike racks around and you get points for it, but they're not used more than you would if you didn't have those bike racks. I've also seen where, most vehicles, I forgot what year it was, but it's beyond like 2016, 2017, somewhere in there. Most vehicles that are new beyond that point meet the low emission vehicle requirements. So now you're just adding signs for pretty much anybody and you get points for it. So that's where I had a little bit of skepticism. I haven't done a LEED project now in years, and the new version that just came out, I believe it was last year, and I think that one, looking through how that one operates, I think they're making a lot of good strides in the right direction. But there's definitely cons to it, but overall, trend in the right direction. And the last piece of it is understanding IAQ versus comfort versus efficiency. All those things kind of sometimes they can go hand in hand, but a lot of times there's trade-offs involved. So in order to meet some of the comfort stuff, we have to give up some efficiencies. In order to meet some of the efficiencies, you have to give up some air quality things. In order to meet air quality, we have to give up some of the efficiencies. So there's a lot of trade-off. It's hard to get that, we're not going to get that perfect situation. So you're trying to balance all these different factors. So it is very difficult, but they all come into play and they all play a big role within the mechanical components of your building, which is why it's, electrical and plumbing is a little more straightforward. We bring power in, we bring water in, we use that stuff and we recycle it and we bring it back out. This is not as easy. There's a lot more moving parts and pieces through the air exchange. So that little PowerPoint just kind of comes into play. I throw a couple questions in for that first quiz, but the first topic is forced air. There's a short video lecture there, and then the lecture that associates with it. A couple other components. So we have some forced air accessories, some forced air practice activities here to do if you'd like to do those as well. Another quick reminder, you have all these options at the side. So once you complete activities, you can always mark them as done as sort of your checklist. Again, for steam and hydronics, we have a video that combines both L9 and L10 here, and then a couple other resources throughout to show how different components work, a little more depth, and then a quiz, refrigeration, air conditioning. I kind of broke these up a little bit differently here. We have refrigeration and superheat and subcooling. I put those as one because there's a little bit more to it than just the refrigeration. So there's these two lectures that go with this video. There are a couple different websites as well for additional resources. And then we jump into air conditioning and cooling, have one sort of longer slideshow there with more components, more resources to review, and then a quiz. A couple other things here. We have energy.gov website and then geothermal heat pump because I didn't really get into that much. I think this is the same link though as in your PowerPoint. I think these are pretty cool units too. It's just the old text that this course was originally based on didn't have anything about geothermal, so we sort of just add things in as we go here to modernize it a bit. And the last piece of it is you have your discussion post as well. A couple short questions, trying to get some good thorough response though, and some communication between the group. And the day after your initial post is due, I will open up just this document for you, which is your just general feedback, general considerations, things that, hopefully with all of that you're doing, all this work, you're learning something from it, and I think that feedback is a big deal. So I want to make sure you get that as soon as possible in case you have any questions. So again, there's a lot of things to review, a lot of things to go through. Ultimately, just grading the quizzes, just grading the discussion posts. So yeah, if you have any questions, just let me know.